In this video, we're going to learn about something called the two-point product test, which is what we use to test for inverse proportionalities. We already learned the two-point ratio test. That's where we took the ratio of the coordinates for two different points. And we use the two-point ratio test when we're looking at direct proportionalities. Now there's something to mention, which is if you say A is proportional to B, A is proportional to B, that is really no different from saying A is directly proportional to B. If you leave out the word directly, then you're implying direct proportionality to B. So you can leave out the word direct, but there are other types of proportionalities besides direct proportionalities. For example, there are inverse proportionalities. So what does that mean? Well, two quantities are inversely proportional. Here's the definition. The product of the two quantities is a constant value. And you could specify it's a constant value, the product is a constant value, even when the quantities themselves change. So even if you change the value of the quantities, their product will always be the same thing. And there's a way we can write this. There we go. We can write this simply with mathematics. We can say A is proportional to the inverse of B, or A is inversely proportional to B, if A times B is a constant. How do you test for this? When problems say something like, when they say use the graph below, test this hypothesis, using the graph, that's a keyword. Test, that's another keyword. It means do the two-point product test. What's that test? You draw a best fit line, although you won't do this very often. You won't have to do this usually for inverse proportionalities, but maybe you need to draw a best fit line. Oops. Draw a best fit line. Next, you choose 2 points and you find the coordinates, the x and y coordinates. Find the coordinates of 2 points on line. It's good for the 2 points to be separated somewhat, like opposite ends of the graph. Then you take the product for each of the 2 points. And finally, you draw a conclusion. Draw a conclusion. Okay. A student conducts an experiment, collects the data below. She hypothesizes, here's a hypothesis, that current through a wire is inversely proportional to resistance of, that should say, the wire. Using the graph below, test the hypothesis. Error bars are too small to be seen. The first thing is current. We use an I for current, capital I. We use R for resistance. We haven't learned that yet. That's okay. Error bars are too small to be seen. Well, when we draw the best fit line, step 1, that means you have to go through all the error bars, but since they're too small, you have to go through every data point. So your best fit line is literally just passing through every data point. And I did a decent job of that. Not great. So when you pick 2 points, they have to be points on the line, which means you can just pick, the best thing to do is just pick out the 2 data points that are far apart from each other. So you could pick these 2, right? Find the coordinates, write down the coordinates. You could just write blank blank and blank blank. But here's the thing, you do want to show IB that you know what you're doing. You want to demonstrate your understanding of the process. So you might say something like I1 times R1 equals, show them exactly what it is you're doing, and then you take the first I value and the R value, and then you do I2 times R2. And that's when you use the second data points, right? And then you calculate the values, equals blah, something, equals blah, blah, blah. And then you draw your conclusion, right? So show the process, show your work on the graph, show this type of work where you're drawing the line, where you're choosing the points, right? Where you're tracing, show the fact that you trace over, like these green lines, show that on the graph as part of your work.